Hello all. We're going to start working on the next lesson. This should be day 30, which means you have a quiz the next time I see you. I don't think you're going to have any trouble with this lesson at all. Really don't. So I think you'll be fine. All right, so let's take a look. Analysis of polynomial functions, numerical, graphical, and analytical approaches. The graph of a cubic function of the form g of x equals ax cubed plus bx squared plus cx plus d is pictured to the right. Use the graph to answer the questions that follow. Based on the graph, what can be concluded about the values of a and d? Let's look at a first. And notice a is your leading coefficient. What do you know about a? Well, here's what I know. I know that my biggest exponent is a 3, so this thing's cubic. An odd degree means the ends do different things. Because this graph rises to the left and falls to the right, a has to be negative. So a is negative because odd degree and let's see, as x approaches negative infinity, g of x approaches infinity. As x approaches infinity, g of x approaches negative infinity. That's why I know a is odd. Now, what about d? Well, d is the constant, which means the y-intercept. So d has to be 1 because it's the y-intercept. Now look at question B. Based on the graph, what can be concluded about the roots of g of x? Well, all I see is one positive root. I see one positive root. So g of x must have 2 imaginary roots. Since the function is cubic. I know the function has to have 3 roots. All right, based on the graph, what is the maximum number of sign changes that the equation of g of x could possibly have? The number of sign changes of g of x, remember, gives us the maximum number of positive real roots. Well, we see 1. Now let me try to explain this since I can't see your faces. Remember that the maximum number of roots, and then if you decrease that by 2 and by 2, as long as you can, those are also possible numbers of positive roots. Since this was a degree 3, it might have had 3 positive roots at maximum, but it also could have had 1 positive root, which is actually what it had. So the maximum, okay, Stenich, you're a dummy. That's the maximum number of roots, which is 3, which means g of x could have had at most 3 sign changes. Okay? Since you just have 1 positive root, but the function is cubic, you could have had a maximum of 3 sign changes. That would allow you to have 3 or 1 positive roots, and you actually ended up having 1. Last question. If the coefficient of the linear term in the equation is -3, so that means the x is multiplied by -3, and g of -1 equals 8, find the equation of g of x. Okay? Ax cubed plus bx squared plus cx plus d. Now I put the -3 in as the coefficient of the linear term. But remember, I also know what d is. D is 1. So I can put that in as well. Okay, g of -1 is 8. So that means if I substitute in -1, I have to get 8 as the answer. So let's see what that gives us. G of -1 is a times -1 cubed plus b times -1 squared minus 3 times -1 plus 1. So that's -a plus b plus 3 plus 1. And we know that that has to equal 8. So what I know at this point is that the opposite of a plus b has to equal 4. Now from looking at that, that keys me that I have another equation that I need to find, because this one equation here has 2 unknowns, so there's no way I can solve it. If I can get 2 equations and 2 unknowns, then I can solve the darn thing. So let's go up there and look and see what we've missed. Let's see. I'm looking at my answer key here, and my answer key shows a point on the graph right here. Does yours? Well, if it doesn't, it's supposed to. So put a point there. So here's what I know. I know the point 1, -2 is on my graph. So that means g of 1 has to equal -2. So let's substitute in g of 1. So g of 1 equals a times 1 cubed plus b times 1 squared minus 3 times 1 plus 1. So what's that give us? A plus b minus 3 plus 1. And what did we say that had to equal? -2, I think. Yeah. So that gives us a plus b minus 2 equals -2, or a plus b equals 0. Okay, now I have 2 equations and 2 unknowns, so I can solve for a and b. So let's see what I've got here. I've got -a plus b equals 4, and I've got a plus b equals 0. Well, I can just add those 2 equations up, because if you'll notice, those add up to give me 0. So I get 2b equals 4, b equals 2. Now, if b equals 2, what does a have to equal? Well, if I substitute it into either one of these equations, not b, a would have to equal -2, wouldn't it? So what is my equation? I'm going to have to erase some stuff. My equation then is g of x equals a x cubed plus b x squared plus cx plus d. There's my equation. Next page. Consider the quartic function f of x to answer the following questions. Use Descartes' rule of signs to create a chart of possible combinations of the type of roots that f of x will have. Okay? Let's see how many sign changes we have in f. 1, 2, so we have 2 sign changes. So positive real roots are going to be 2 or none. Negative real roots. Remember, we have to do f of the opposite of x. Well, f of the opposite of x is going to give me the opposite of x to the fourth plus 3x squared plus 2x minus 2. Sign changes 1, 2. Now, is 0 a root? Do I have a GCF that's x to a power? Nope. So let's write our chart. Positive, negative, 0, imaginary. I could have 2 positives and 2 negatives. I could have 2 positives and no negatives. I could have no positives and 2 negatives, or I could have no positives and no negatives. 0 is not a root ever. The degree is 4, so I know I have 4 solutions. Top row would mean no imaginaries. Second row would be 2 imaginaries. Third row would be 2 imaginaries, and the fourth row, they'd all be imaginary. Sketch a graph of f of x on the axis pictured to the right. Then determine which combination of roots from your table in part A is correct. Give a reason for your answer. You don't know what that looks like, neither do I. All I know is the y-intercept's -2. I know that's an even degree with a leading coefficient that's negative, so both ends open down. That's about all I got. Go to your calculator. I want you to graph it. Okay. So you're going to sketch that, and I want you to pay careful attention when you sketch. Both ends open down. You've got a 0 in there that's almost to -2, but not quite. You've got a 0 that's where they're in between 0 and -1. And then you've got your y-intercept. So we've got a 0 that's almost at negative. Oh, snap. Come on, Stennett. Almost at -2. About halfway between 0 and -1/2. Y-intercept's at -2, and both ends open down. So something like this. Which of those 4 combinations of roots works? Well, it looks to me like I see 2 negative real roots, and that's all I see. So it looks to me like it's this one. Give a reason for your answer. Well, the graph crosses the x-axis when x is negative twice, and that's the only time the graph crosses the x-axis. So that means the other 2 roots have to be imaginary. Use your graphing calculator to determine the coordinates of the relative maxes and relative mins. Then state on which intervals the graph is increasing and decreasing. So what I need to find that point, and that point. All right, let's go back to your calculator. We're going to go after this point. That's a maximum. Second, no, Stennett. Second calc max. Left side. Right side. Enter. Okay, I'm writing these down so that I can write them on the smartboard when we go back there. So one of your maximums, round to 3 decimal places, negative 1.366, comma 2.848. Now I'm going to go after this maximum right here. Oh, that one's nice. So this really, right here, that's just 1. So 1, negative 2. Okay, so relative max. And what were those numbers? Negative 1.366, comma 2.848, and 1, negative 2. Then we'll go find the relative min. .366 and negative 2.348. Now let's answer the rest of the question. State the intervals on which f is increasing and decreasing. I don't want to erase those numbers, so I'm going to put the answer to that part up here. F is increasing on negative infinity to where? To right there. Negative infinity to negative 1.366. And from here to here. So where's that? 0.366 to 1. Remember, you're only using the x values, never the y. F is decreasing here. So between, let me see here, negative 1.366 and, let me see here, and the x value of the minimum. And where else is it decreasing? Well, it's decreasing right here. So from that second maximum, 1, all the way to infinity. Wow. Okay, let's look at the last question there. Find the coordinates of the points of inflection. Well, let's take a look at that picture. And let's talk about where this graph is concave up and concave down. We're concave down, then we change to concave up, then we change to concave down. So we're concave down, concave up, concave down. That should mean 2 points of inflection. So somewhere about in here and somewhere about in here. Now remember, we can find a point of inflection by finding the midpoint between relative extrema. So I'm going to find, I need a better color, a different color. Let me see. I wonder if you can see, I don't know, can you see that one? Between this relative maximum here and this relative minimum here. So what are the x values going to be? Let's see, between that relative maximum and that relative minimum. So add those up and divide by 2 for the x value. Add those up and divide by 2 for the y value. So we should have, if you've done that on your calculator, we should have a point of inflection, and you can abbreviate that POI. If you add those x values up and divide by 2 that I underlined kind of in that lavender, that should be like -0.5, and the y value should be 1/4. There's a point of inflection. Now let's look at that other point of inflection. So we found this one. Now let's go find this one. Let's see if we can find another color, maybe orange, maybe, between here and here. So we're going to go between this relative minimum and this relative maximum. So we're going to add those x values up and divide by 2, add those y values up and divide by 2. If we do that, we should have, if you do that on your calculator, about 0.683 is the x value and -2.174 for the y value. So those are your 2 points of inflection. Now state the intervals where the graph is concave up and concave down. There's a lot of stuff going on here, huh? I'm going to just have to erase this because that's just going to make my head hurt, all those different colors. So that was something like this, something like that. Okay, so this function is concave down from here to in there. So let's write that down. Oh, snap. I don't know what happened there. Concave down. Now remember, you're using your x values. From that from -infinity to that x value right there, we're concave down. So from -infinity to -0.5, this graph is concave down. Is the graph concave down anywhere else? Yep, concave down in that area. So that x value was this one right here. So we're also concave down from 0.683 all the way to infinity. This graph is concave up just right here. So that graph is concave up between -1/2 and 0.683. If you have any questions, get Ms. King to help you or help each other, okay? We have one more page to do. The equation of a cubic polynomial function is f of x equals, and f of 2 is 0. So let's make sure we don't forget that. Determine the left and right hand behavior of the graph. Okay, we have an odd degree. We have a negative leading coefficient. So odd degree and negative leading coefficient means, what do you know about your end behavior? You know, they go opposite ways. You know, the left hand is going to go up and the right hand is going to go down. So as x approaches -infinity, f of x will approach infinity. As x approaches infinity, f of x will approach -infinity. If f of x is divided by the factor x minus 2, what will the remainder be? Now you have to be real careful. When Sparks uses the word factor, the word factor really means that that number will go into that polynomial evenly, which means the remainder has to be 0 for the thing to be a factor. So we sure hope the factor is going to be 0, or the remainder is going to be 0. So let's see. If we do synthetic division, we're dividing by 2. The numbers are -2, 2, wait a minute, k, and 4. Now, wait a minute. You remember what I told you we can't forget? We already know what the remainder is going to be from looking right there. If we divide synthetically by 2, remember the remainder is just the y value when the x value is 2. So this tells us right here that the remainder is going to be 0. So what will your remainder be? The remainder is going to be 0. Why? If x minus 2 is a factor, then x equals 2 is a root, or a 0. So the point 2, 0 is on the graph. Now, I'm gonna talk way too much here, and I know that. The point 2, 0 is on the graph. The remainder is the y value. So the remainder must be 0. Look at C. Find the value of k in the equation. Now I think I can probably do what I started to do last time. Because I know if I divide by 2, I know I have to get 0 as a remainder. -2, 2, k, and 4. So what's that? -4, -2, -4, that's k minus 4. That's 2k minus 8. Add those up, that's 2k minus 4. 2k minus 4 has to equal 0. So k has to equal 2. All right, determine all the roots of f of x. All right. Well, I know one of them. One of them's 2. I was told that. So what if we divide synthetically by 2, but k is 2? That's a lot of 2's. That's -4, -4, -4. That function that we started with was cubic, which means the function that we are left with right here is quadratic. -2x squared minus 2x minus 2 equals 0. Don't you ever attempt to factor when that leading coefficient is negative. I'm going to factor a -2 out of that bad boy. And that'd be x squared plus x plus 1 equals 0. Now, if I divide both sides of that equation by -2, I'm going to get x squared plus x plus 1 equals 0. I can work with that. Sadly, it won't factor. The coefficient of the middle term is odd, so I don't want to complete the square, so I guess I'm going to quadratic formula. X equals -b plus or minus square root of b squared minus 4ac all over 2a. So x equals -1 plus or minus the square root of 1 minus 4. Okay, so x equals -1 plus or minus I times the square root of 3 all over 2. So there are 2 of your answers right here. And your other answer was x equal 2. So this graph, this function's got 2 imaginary roots and 1 positive real root. And because it was cubic, if I can go all the way up here, that's all I'm looking for. So that was the answer to that part, right? Find all the roots, show your work. Okay, find the coordinates of any points of inflection. Well, I guess that means we got to go graph it. So let's go graph it. Negative 2x cubed plus 2x squared. Didn't we get 2 there? X plus 4. I'm going to do a zoom 6. Okay. I see my 0 of 2. I see my y-intercept of 4. Good. Now let's talk concavity. Well, this graph is concave up, and then it changes to concave down. So thankfully, I just have one point of inflection. So that point of inflection is somewhere in there. I can find that point of inflection by finding the midpoint between those two relative extrema. So I'm going to find that relative min and that relative max and find their midpoint, and that'll be my point of inflection. Oh, snap, that's not what I wanted to do. Minimum. Okay, I'm going to have to write those down. Negative 1/3 and 3.629, 3.630. That's my relative min. And then that relative max is 1/6. Well, that's easy. So I'm going to find the midpoint. Let's write those down now. Between negative 1/3, 3.630, and 1.6. This got 1.616. All right, so the midpoint, negative 1/3 plus 1, what's that, 2/3? And 2/3 divided by 2 is the same as 2/3 times 1/2. What's that, 1/3? So the y value, the x value of your point of inflection is 1/3. 3.63 plus 6 is 9.63 divided by 2. 9.63 divided by 2. What's 9.63 divided by 2? Fiddle, surely I don't need a calculator to do that. 4.815. Let's see. 4.815 times 2, that's 0.36. Yeah, that's right. There's your point of inflection. Now let's see if that makes sense. 1/3 and 4.8-ish. Does that make sense here? Right in this area right here? That's pretty good. I'm happy with that. And I think that's it. I hope this lesson's pretty easy for you. I really feel like we're just pulling together a lot of things that we've been working on into one lesson. So you work on this, and I believe your quiz is the next time. We'll have a little bit of time before to work on anything you need here, and then we'll take your quiz. See ya.